But personalized medicine kind of changes the order of that. It's not by guideline. It's medical practice based on your specific needs of your body. And genomic medicine actually forms the largest component of personalized medicine, and it's these order and organization of the A's, C's, G's, and T's. And so what I'm going to do now is go through a few different applications of genomic medicine, and from general practice all the way through idiopathic disease. It's important to understand, though, that the genome sequencing is a universal genetic test, and the real promise of genomic medicine relies on genome sequencing. Your genome, the order of those A's, C's, G's, and T's are fixed at fertilization. They're set. And from that moment to your last breath, they're not going to change. So we sequence the genome one time, and we refer to that data set over and over and over throughout your lifetime to help improve the quality of medicine. So when you go to the doctor, one of the first things they do is take your blood pressure, right? So what do? They take a balloon, they wrap it around your arm, they pump it up full of air, they constrict the blood flow to your lower extremity, they put a stethoscope on your arteries, and they listen as they let the air back out for when the blood begins to flow back into your arm, and they look at a pressure gauge. Well, that's great, but that's reactive medicine. In other words, they're telling you what you have, whether or not you have high blood pressure, not whether or not you're going to get high blood pressure. Now, I use this as an example because genomic medicine can give you predictive qualities. Now, behind me, this is a rather complicated chart, and it's only important that you take away that those symbols in red, those are variants that have been associated with high blood pressure and getting high blood pressure, right? So there's a genomic architecture that we can know and test in advance. In fact, I've had this done for myself, and we can summarize the results of those 29 variants as a simple chart of relative risk. So I have a relative risk of 1, which means that I have about the same chance of getting high blood pressure as other people of my ancestry. We can even extend this to look at what my lifetime risk will be, and that's about 55% chance. But we can do this for much more than just high blood pressure. We can do it for lots of different diseases like prostate cancer. And this is, again, my risk for prostate cancer, which is slightly less than other people of my ancestry. But it's not the same for everybody. In fact, Jeffrey Gulcher, this is his result for prostate cancer. He's a world-renowned clinical medical genomicist, and he has twice the background risk for getting prostate cancer. So Jeff, 48 years old, went to his doctor, and he said, "Doc, I got increased risk of prostate cancer. Would you give me a PSA test, a prostate-specific antigen test, a blood test?" And the doctor said, "Well, Jeff, you're 48 years old. We've been checking your prostate. There's no swelling. Everything's fine. You're fine. And we don't do PSA tests until you're 50. But Jeff prevailed upon his doctor, got the PSA test. In fact, his PSA was high. He biopsied his prostate, and Jeff indeed had prostate cancer. Took the prostate out. In fact, he had a very aggressive form of prostate cancer that would have killed him. In this case, he was able to get that done 2 years before he would have had his first PSA test. That's just an example.
Your body is a very complicated system, which means your instruction manual needs to contain a lot of information. Scientists embarked on the first full reading of this instruction manual in 1990 with the Human Genome Project, which took 13 years and cost $2.7 billion. Since then, we've had huge leaps in technology, which now make these readings much faster and less costly. Scientists want to better understand the unique differences in our genomes. These differences are called variants, and these variations make us individual. For example, giving us different eye colour or hair colour. Most of these variations have no effect on our health. However, some have been shown to cause or contribute to certain health conditions. Scientists have also discovered that these variations in our genome can influence if we develop a disease, how that disease progresses, and how we respond to medications. Our genome is not the only thing to influence our health. Lifestyle and environmental factors, such as diet, activity levels, and stress, also play a part. The scientists at Genomic Medicine Ireland are studying the genomes and lifestyles of tens of thousands of people in Ireland to better understand how changes in our genome and lifestyle affect our health. We hope to use this information to help prevent and treat disease and ultimately improve our country's future health.